Problem F9-6. Locate the centroid z-bar of the homogeneous solid formed by revolving the shaded area about the z-axis. So since we are looking for centroid, that is the center of volume, we can use the formula z-bar is equal to the integral z dv divided by dv. Now, if you are familiar with Calculus 3, you can solve this problem using cylindrical coordinates simply enough. I'm going to assume that you have not taken Calculus 3, and so I'm going to solve it in a way that does not require multiple integrals. So what I'm going to do is I'm going to recognize that this shape right here can be sliced up into a bunch of different circles. These slices are all in planes parallel to the xy plane. And in each case, the radius of each of these slices is given by the value y of this formula. So z is equal to 1/3 times 12 minus 8r. We can solve for r and say that the radius of any individual slice is equal to 1/8 times 12 minus 3z, where z is the z position. That means that each of these circles, they're actually disks. They have a radius given by this formula right here and a width of dz, which means that the volume is pi r squared, so the area of the circle, times the width dz. So pi and then squaring this gives this dz. So to find the centroid, we integrate z times dv, and dv is given by this form right here. So dv is now in terms of dz. Our bounds are from 0 to 2 feet. It should be from 0 to 2 feet, but because this formula is playing a bit fast and loose with units, we are going to as well. Just assume that all of these have the proper units. Basically assume that this is 12 feet. If this is 12 feet, then this works. But anyway, you take this formula for dz, or for dv, plug it into the numerator. Remember, in the numerator, it's dv times z, so each of these terms gets multiplied by z. So 144 becomes 144z. And then in the denominator, we just integrate this function as it is, dz. Now before I integrated, I said there's a pi up top and a pi up bottom. Those pi's are constant, so they cancel out. And the over 64s on top and bottom also cancel out. So we could say we're left with just 144z minus 72z squared plus 9z cubed at the top, and 144 minus 72z plus 9z squared at the bottom. Integrating these terms, and again realizing that with boundaries going from 0 to 2, because z goes from 0 at the bottom point to 2 at the top point, gives us 144z integrates to 1/2 times 144z squared. Negative 72z squared integrates to negative 72 over 3z cubed. And 9z cubed integrates to 9 over 4z to the 4th. Down here at the bottom, 144 integrates to 144z. Negative 72z integrates to negative 72 over 2z squared. And 9z squared integrates to 9 over 3z cubed. Plugging in the bounds goes from 0 to 2. You get this formula right here. Simplifying each of these terms individually gives us this, which when we add them together becomes 228 over 168, which simplifies into 59 over 42 feet. Apologies for the jump. I just realized I made an arithmetic error. But plugging in the values of 0 and 2 into our bounds, we get this right here, which simplifies to these numbers. Add these together, we get 132 over 168, which simplifies to 11 over 14 feet. Now, one reason why I knew that my original answer was wrong is because given this shape right here, the centroid should be in the lower half. It should be less than 1 foot. Because this whole thing is 2 feet tall, weighted towards the bottom, it should be less than 1 foot. The answer I had before was greater than 1 foot, so I rechecked my arithmetic and I found this correct answer.